Dear students, in the previous lecture of P block elements, we are discussing the compounds of the oxygen family. Oxygen family, particularly O2, O3, these compounds we have already discussed. In case of sulfur, we have discussed allotropes of sulfur particularly, that is alpha sulfur, beta sulfur. Okay. Now today we are going to discuss some other compounds of the sulfur, particularly sulfur dioxide is one of them. Okay, so if you talk about the sulfur dioxide, first we will start with the preparation. So sulfur dioxide can be easily prepared in the laboratory by burning the sulfur, which will result in the production of the acetone. If you want for commercial production, it is industrially prepared by the sulfide ore, particularly as a byproduct while doing roasting. At that time, particularly oxides of metal and sulfur dioxide is produced as a byproduct at a large scale. So these are the two methods. This one is for the production, and this one when you need it in the purified form, that you will burn sulfur particularly to give sulfur dioxides. Okay. Now, if you go for the properties, so if you go for the physical properties, it is colorless, having pungent smell, solubility highly soluble in water, sulfur dioxide particularly here. Okay. This can you also show by the reaction, that when sulfur dioxide put it in the water, it will result in the formation of sulfurous acids. Okay. Its molecule, if you talk about it, the molecular structure is angular for the particularly sulfur dioxide. The structure is angular molecule. Two canonical form resonance hybrid is possible for the sulfur dioxide particularly here. If you go for the chemical properties, so in an alkaline medium, sulfur dioxide readily form sulfite particularly. If sulfur dioxide is available in larger quantity, then sodium sulfite react with more sulfur dioxide. If sulfur dioxide is in excess, then it will form in the result of sodium hydrogen sulfite particularly. This reaction particularly show that sulfur dioxide is acidic, or its nature is same as comparing to the CO2 gas. Okay. Sulfur dioxide also form different kinds of, this is the first property showing the acidic character. The second property you can show about the chemical property, that sulfur dioxide easily react with the chlorine in the presence of charcoal to form sulfuryl chloride. And sulfur dioxide also react with the oxygen in presence of the vanadium oxide to convert into sulfur trioxides. So this is the chemical property, second chemical property you can show about the first one, which showing the acidic character. That's why we show the reaction with the alkali. The second one, some non-metals, with depending on the catalyst, the product will be different. The third chemical property, which is the important property for the sulfur dioxide, that sulfur dioxide behaves as a reducing agent, a good reducing agent. Sulfur dioxide easily decolorize potassium permanganate, result in the formation of sulfate, converting manganese to Mn2 positive. Particularly in a acidic medium, the reaction will be more formed. But you know that sulfur dioxide easily get decolorized permanganate by reducing the manganese oxidation state. So it will do the reduction particularly. So sulfur dioxide is behaving as a good reducing agent. It also convert Fe3 positive to Fe2 positive, showing its reducing behavior. You can show the reducing behavior with any particular reaction here. Now, if you go for the uses, So sulfur dioxide is used in a lot of chemical processes. Sulfur dioxide is used in production of chemicals like sulfuric acids. That is one of the most important chemical. It is also used as a disinfectant, anti-chlor. Anti-chlor mean to say where you do not need chlor, because sulfur dioxide easily react with the chlorine to form sulfuric chloride. So remove the chlorine from any environment. So anti-chlor, it is acting as there. Okay. Liquid SO2, liquid sulfur dioxide can act as a solvent too for many particular solute in inorganic chemicals. So liquid SO2 is used as a solvent. So these are the preparation, production, properties, physical, chemical, and the uses for the sulfur dioxide compound. Now the last compound in the oxygen family is Oxi acids of sulfur. Sulfur form a large kind of Oxi acids there, which important one are the H2SO3, that is sulfurous acids. If you go for its structure, this one have one lone pair over it, and 2 basicity, 2 particularly for this sulfurous acids. Okay, if you go for the H2SO4, that is sulfuric acid, the structure will be, that is also dibasic acid, but in this there is no lone pair as sulfur have. Then the next one is the peroxy disulfuric acid. Peroxy disulfuric acid. In this particularly the formula is H2S2O8. Mean to say that is also acting as a dibasic. So sulfur is related to particularly in this form. One OH is to particularly one, and then 2 oxygen. One oxygen with each sulfur. This one also with the another sulfur. And this is the particularly structure for the peroxy disulfuric acid. The another important one is the pyro disulfuric acid. The formula for this one is H2S2O7. This is the important one. It is also known as oleum. Now what is the structure? This one oxygen is less. So that's from this bonding we will remove one oxygen particularly here. Though both sulfur is SOS is bond is present in this case. Okay, in no particularly other acid we have shown SOS bond. In this particularly it is present, that is oleum particularly. We will also discuss that why this one is important one, because it is helping in the formation of the sulfuric acid. So out of these oxide acid, you very well know that H2SO4 is the most important acid, sulfuric acid that is. So this is prepared by the contact process. The process is known as contact process. I am telling you today only the main steps particularly. The detailed discussion about the contact process we will discuss tomorrow in the next lecture. That for H2SO4 there are 3 main key steps. Production of sulfur dioxide from sulfur or sulfidors. This is the first. So we have the sulfur dioxide in the first step. Conversion of sulfur dioxide to sulfur trioxides in presence of sulfur vanadium oxides. Which the third one is absorption of sulfur trioxide in H2SO4 to give oleum. Oleum is again your H2S2O7 there. So these are the main 3 steps regarding the production, or these are the key steps for the production of the H2SO4. Now you very well know that conversion, this particularly I have already shown you in this reaction, that sulfur dioxide in presence of oxygen convert into sulfur trioxides. So this is if you go for is a exothermic reaction particle. So, and one more thing, you can see that by balancing this one particularly, let me balance this one particularly for you first. So this is the balancing. You can easily see that volume is decreasing because three molecules are producing one molecule. So that's why low temperature and high pressure, low temperature and high pressure is the necessary conditions for the conversion of sulfur dioxide to sulfur trioxide, or you can say how you can enhance the production of H2SO4. The best condition you needed are the low temperature and high pressure. But still, we do the process at 72 Kelvin and 2 bar pressure because at very low temperature, the reaction rate becomes slow. That's why the temperature is raised a little bit, but the pressure is increased to a considerable amount. So these are the two necessary conditions for in the contact process for the production of the sulfuric acid here. Now, today you have completed the sulfur dioxide and contact process oxi acids, particularly sulfurs we have discussed. Contact process we will complete tomorrow. So today you will read the topic we did. Second thing you will do, make your notes in fair notebook there. Third thing, sort out 10 short type Q's and answer in rough notebook there. Okay, thank you.